The rational function is defined as a function, the quotient of two polynomial functions, p of x divided by q of x. We are not worried about p of x, our concern is about q of x, so the condition shouldn't be 0. And I'm gonna add one more condition. The q of x shouldn't be constant, meaning the minimum degree of q of x should be 1. Otherwise, it will be a polynomial function. The simplest rational function is the reciprocal function 1 over x. I'm going to do a quick sketch for the graph. To see the domain and the asymptotes. The graph is continuous everywhere except at this point, which is the 0. So domain is r minus 0, or can be written as from negative infinity to 0, union 0 to plus infinity. The second part, we're going to talk about asymptotes. Like many rational functions, it has branches going to a certain x and y values. These values are the asymptotes. The line holding these values are called the asymptotes. Graphically, to the right and to the left, the graph is going very close to this line, but it doesn't cross it. So this line, which is the x-axis, is called the horizontal asymptote. Upward and downward, the graph is going very close to the y-axis. So this is what we call it, the vertical asymptote. So the vertical asymptote is x equals 0. The horizontal asymptote is y equals 0. Using our knowledge of continuity and end behavior, limit when x goes to 0 from right, this is 0 from right, the graph is going to plus infinity. And limit when x approaches 0 from left, this is the left, the graph is going to negative infinity, proving that 0 is the vertical asymptote. Limit when x goes to plus or minus infinity, the graph is going, as we said, very close to the x-axis, which has the value of 0, proving that the horizontal asymptote is y equal to 0. And here we come to the nice part. Graphing rational functions and the steps are listed below by finding the domain first, and then the asymptotes, and then the intercepts, and then taking special points within the interval to graph. I'm gonna list the first one. 6 divided by x plus 3. First, let's find the domain. And the domain can be found by finding the values of the denominator, what we call it the restricted value. So simply, we solve the denominator. So we say the domain is r minus -3, or from -infinity to -3, union -3 to +infinity. Step number 2, the asymptotes. By solving the denominator, already we found the vertical asymptote. So the vertical asymptote is x equal -3. The horizontal asymptote, y equals 2. It depends on the degrees of a numerator and denominator. The degree of the numerator is 0 because there is no x, and the degree of the denominator is 1. Degree up less than degree down, so directly you say the horizontal asymptote is 0. Step number 3, intercepts. I'm gonna find the x-intercept by putting y equal to 0, which is the g of x, leading to 0 equal 6 over x plus 3. Cross multiply leads to 0 equal 6, which is impossible, meaning there is no x-intercept. The graph doesn't cut the x-axis. Y-intercept, we put x equal to 0, leading to y equal, or g of x equal 6 divided by 0 plus 3, which is 2. So the crossing point is x equals 0, y equal 2. Graphing. So first, I like to graph the asymptotes, and we said the vertical x equal -3 and the horizontal y equals 0. So x equal -3, 1, 2, 3. And 0, which is the x-axis itself. Intercepts, no x-intercept, the y-intercept is 0, 2. X equals 0 and y equal 2. Special points, I prefer to put in the middle the vertical asymptote, because the vertical asymptotes, they determine the branches of the rational function. To the left, take as many points as you want. I'm gonna take 1 point to the left, 1 point to the right. If it's not enough, then I take more points. For x equal -4, replace, so let's do calculations here. 6 divided by -4 plus 3, which is -6. This is the asymptotes. For x equal -2, 6 divided by -2 plus 3, which is +6. So -4, -6, -4, -6 is here. -2 and +6, let's say here. The two branches, let me extend. As we mentioned, if you need more, you take more. But I think the branches are clear where to be. And remember that the branches are limited by the asymptotes. In the coming question, we're gonna discuss when the graph has a hole. So let's say we have a function h of x equals x to the power 2 minus 4 divided by x to the power of 2 minus 2x minus 8. The first thing we have to do is factoring. So I'm gonna factor numerator and denominator. X squared minus 4 can be factored as x minus 2 into x plus 2. The trinomial down can be factored x and x. The two numbers I'm looking for, their product is -8 and their sum is -2, -4 and +2. Okay, to the right, I see that x plus 2 is a repeated factor, up and down, could be simplified. And this is where we have a hole. So if we take the domain, so the denominator shouldn't be 0, so x minus 4 equal to 0 or shouldn't be 0 to find the restricted values. So x equal 4, which makes the denominator 0, x equal 4. Knowing that, also x shouldn't be -2. X shouldn't be 4 or x equal 4 is what we call it vertical asymptote. X equal -2, what we call it hole. So the graph at x equal -2 has a hole, and the graph at x equal 4 has a vertical asymptote. So domain is, if we put the two numbers in order from -infinity to +infinity, -2 and then 4. So domain is from -infinity till -2, union -2 to 4, union from 4 to +infinity. B, as we mentioned, the vertical asymptote is x equal 4. The horizontal asymptote, it depends on the coefficients of the numerator and denominator. Since the greatest x is x to the power of 2, so it's x to the power of 2 divided by x to the power of 2, and here 1 and 1. So simplify them. So the horizontal asymptote is y equal 1. Intercepts. I'm gonna find x-intercept first. To find x-intercept, we put y equal to 0. Then 0 is equal to, replace y by 0. So 0 is equal x minus 2 divided by x minus 4. Cross multiply, which means that x minus 2 is equal to 0. Solving, we get x equal to. So the point is x equal to and y is 0. For the y-intercept, we put x equal to 0. Replace x equal to 0, then y equal 0 minus 2 divided by 0 minus 4, which is 1 over 2. And the point is x is 0 and the y is 1 over 2. The vertical asymptote in the middle, x equal 4, we found it earlier. 1 point less, 1 point more. Let's do calculations to find y equal, replace 3 minus 2 divided by 3 minus 4, which is -1. Replace x equal 5. 5 minus 2 divided by 5 minus 4. 3 divided by 1, which is 3. Graph. The vertical asymptotes first. X equal 4. And y equal 1. So I would like to remind you about what we have done the first. The simplified factor x plus 2, we found x equal minus 2 has a whole. So at x equal negative 2, we're not gonna forget to put a whole. So the special points x-intercept to 0. The y-intercept 0.5. And at x equal negative 2, when we graph it, we put a whole. Special points for x equal 3, negative 1. 3, negative 1 is here. And 5, 3. X equal 5. 3 is here. So graphing from the asymptote to the asymptote. And at x equal negative 2, the whole. And the other branch from the asymptote to the asymptote also. The third graph, f of x equal x squared minus 7x plus 10 divided by x minus 3. And I chose this one to show you what's gonna happen when the degree up greater than degree down. So the first thing, we find the domain by solving the denominator. We get x equal 3. So the domain is from negative infinity to positive 3 union 3 to positive infinity. And by default, x equal 3 is the vertical asymptote. Factoring to see if we have a whole. So x and x, negative 2 and negative 5 divided by x minus 3 cannot be simplified, so there is no whole. There is no whole. Horizontal asymptote, degree up is 2 and degree down is 1. Degree up greater than degree down, so no horizontal asymptote. Instead, there is what we call it oblique or slant asymptote. How do you find the oblique asymptote? We have to divide the two polynomials using long division or synthetic. I'm gonna use synthetic. So one, the coefficients of x squared, negative 7, the coefficient x, and plus 10. divided by x equal 3. One is the same down, multiply, add them, we're gonna get negative 4. 3 times negative 4 is negative 12, plus them, we're gonna get negative 2, and this is the remainder. So f of x can be written as the quotient is 1 multiplied by x minus 4. So it can be written as x minus 4 plus the remainder, which is negative 2, divided by the same, which is x minus 3. The one here is the oblique asymptote. So going to the next step, we're going to find the intercepts. The x-intercept, we put y equal to 0, and we replace zero equal. We found already x minus 2, we factored 4 to x minus 5, divide by x minus 3, equal to 0, over 1, cross multiply, leading to x minus 2, x minus 5 equal to 0. From here we can say x equal 2 or x equal 5. So the points 2, 0, 5, 0. To find the y-intercept, we put x equal to 0, and we replace zero minus 2 into 0 minus 5 divided by 0 minus 3, which is negative 10 over 3. And the point is 0, negative 10 over 3. We're going to take special points. The vertical asymptote is here, x equal 3. 1 point to the left, 1 point to the right. Replace to find y, 2 minus 2 to 2 minus 5 divided by 2 minus 3, which is 0. The other one, replace 4 minus 2, 4 minus 5 divided by 4 minus 3, which is negative 2. To graph the asymptote, the oblique asymptote, y equal x minus 4, table of values, Once I take x equals 0 to find y, and once I take y equals 0 to find x, replace x equal to 0, so y equals 0 minus 4, which is negative 4. And then we replace y equal to 0, x minus 4, which means that x equal positive 4. X and y axis. The vertical asymptote, x equal 3. The oblique asymptote, we plot the point 0, negative 4, 0, negative 4, and the point 4, 0, 4, 0 is here. This is the oblique asymptote. Special points, x-intercept, y-intercept first, 2, 0, 5, 0. Two, 0 is here, 5, 0 is here. The y-intercept, 0, negative 10 over 3. 0, negative 10 over 3. Special points, 2, 0 already there. We need to plot 4, negative 2. This is 4 and negative 2 here. The branch to the left from the asymptote to the asymptote. And the right branch from the asymptote to the asymptote.